Hello, in this video I'm going to show you how to move objects using translation. So we got this object spinning right here. I'm going to stop it from spinning. You can have an object spinning, that doesn't honestly really matter. So if I change all these to 0, it will stop spinning. But you can use any object you want, 2D, 3D, model, doesn't really matter. Save, refresh. So we got this object. It is a 3D object, but we're just seeing the front of it. So the x-axis would move it that way, y-axis would move it that way, z-axis would move it inwards and outwards. So WebGL uses a right-handed coordinate system. I'm going to have a separate video covering the difference between left-handed and right-handed coordinate system, but just quickly go over it. Right-handed, a positive value moves right, negative value moves left. In the y-axis, a positive value moves up, a negative value moves down. In the z-axis, so backwards and forwards, positive value moves out of the screen, so like towards you, and a negative value moves away from you, so it gets smaller. So, but I've got a separate video covering that in a bit more depth. That's essentially what it is. So what you want to first do, you can probably put you can have actually tested it, put it wherever you want, but I like to just put it where I'm drawing it, especially it's good for updating as well. So we're just gonna create a few variables, so var tx, and this is just gonna be the translation amount in the x-axis. I'm gonna assign this to 0.0 first, and I'm gonna assign them all to 0.0 just to make sure it's all working, we get no errors, and then we'll actually change the value. 0.0, and then we need to create a translation. So var translation equals gl.get uniform location, and you pass it into your shader program, which we'll be modifying in a second. You specify the variable name inside of the shader program, which again we will be sorting out in a moment. And there's only one last thing to do, that is gl.uniform translation. So we're just passing that in, and we're passing in these three values for it. Okay, so what we want to do now is actually go to our vertex array, our vertex shader. That's where we handle like the positioning, all that stuff. And just here, we're going to create a new variable. This is going to be called uniform vec3, because we're expecting three values, x, y, and z. And I'm going to call this translation. For a comma, make sure to put a semicolon. Could you be using the old method that I used to use, which was using the plus? I changed it partway through the series using this .join method. Now either way is fine. And you just need to add this to the position. So right here, you should just do plus translation, and that's it. So if I refresh, we got some errors. This is basically what I wanted to check before I put any values in. 311 GL uniform is 3F, free float values. There we go. Okay, so if we put a positive value for x, it'll move it right. So if I put like 2.0 and I refresh, as you can see, it's moved it right, and you can see part of it. And naturally, if I put a negative, it'll move it left. If where have I gone now? If I put a positive value here, I'll do a different value just to demonstrate. You'll move up, and obviously, if I put negative, it will move down. Now with this, a positive value moves it towards you. So if I put 1, so as you can see, it's coming a little bit towards us. And if I put like -10, this is pretty far now. There we go. So what we're going to do as one little extra cool thing is we are going to make it move away from us. So we'll set these back to 0. And outside of the animate method, I'm going to have a var, and I'm going to call it z translate equals 0.0, and for this I'm going to set this equal to z translate, and this every single time this is run, will increase as Z translate. So Z translate plus equals 0.01. Let's see how that looks. And I wanted it to move away from us. So we could actually do with it being a bit faster, to be fair. There you go, a little bit faster. And let's move it down a bit. So we can see the bit at the top as well. And that sort of, shakiness, you just need to factor in the, delta time difference as well. So we got, dt, and we just need to multiply it. So we would just need to do times dt. Obviously that's a little too fast. If I do that, this will just make it, consistent on all, systems. But that is it. That is how you move objects using translation. If you have any questions, feel free to pop me a message. Feel free to check out the GitHub page for all the source code. And as usual, I look forward to seeing you in the next video.